Okay, well, we'll go ahead and get started. Thanks for coming back. Day 3 of our 2021 CIP Informational Workshop. You guys are the hardcore attendees. 32 of you are here now, of us. Day 3 today, we're going to hear from Kyndall Jackson on, she's a subcontract administrator, and she'll present on some details around procurement and contracting. And then I'll go through the design evaluations as part of some of the topic areas, and then a few more CIP considerations, including tech support, LCOE calculations, and outreach materials. And then we'll end the day on a little something different. It's a discussion on the goals and the future objectives of this long-running, popular, successful CIP program. And then on tomorrow, we'll have these individual sessions starting on the hour at a different Zoom link provided in the calendar item. We each leader of the sessions will present some details around the topic area, including scoring criteria, and then we'll have plenty of time for Q&A. And so pop into the sessions of interest tomorrow. And we'll record those again and split them into individuals and post those in case you need to go back or in case anyone has missed those. All right, if you have any questions, ask Ian. That sounds good. So Kyndall, I'll turn it over to you now. Thank you.
Okay, great. Thank you, Brent. As he mentioned, my name is Kyndall Jackson. I'm a subcontract administrator with the Acquisition Services Office at NREL. You can go to the next slide, Brent. And I'm just going to be talking to you about submitting a proposal and how that works. So when a request for proposal is posted, we post that to beta.sam.gov, which used to be known as Federal Business Opportunities. All of the instructions for how to submit a proposal will be enclosed in the RFP itself, as far as who to send it to, all the requirements, as well as the deadline for proposals. Those will all be clearly outlined in the RFP. As far as timeline, historically, RFP has been released in late February, and we've pushed for a submission date around late March. Awardees are generally selected in the summer with a goal to award by fall. There's also an opportunity to ask technical questions, and the deadline for those questions to be received will also be provided in the RFP. Once we've gathered all the questions, we will provide all the questions along with NREL's responses to those questions in an amendment that will also be posted to beta.sam.gov within the solicitation. Once we receive all the proposals, they go through a best value selection, which means that we compare both the qualitative merit and price. Merit is identified also in the RFP. These can be things like technical approach or experience, and we'll clearly state what it is that NREL is looking for, along with the percentages that each criteria is weighted by, so that offers will have a good idea of how their proposals will be scored. The evaluation process, we first go through just an initial evaluation for acceptability, at which point NREL may ask for clarifications. Then the proposals are evaluated against the statement of work and that merit criteria I just discussed, and at which point NREL may go into discussions with offers. And then after that point, successful and unsuccessful offers are notified, at which point we begin negotiations with the end goal of making an award. Next slide. Some of the requirements that will be outlined in the RFP include the price participation. So historically, we've seen a minimum of 20% price participation of the total subcontract amount. So you just need to make sure that you're meeting whatever that minimum is. This will be built into the deliverable payment schedule, which I'll discuss a little more in the next slide. And common types of price participation include labor, equipment, and supplies. For the allowable cost, what makes a cost allowable within your proposal, it needs to be reasonable and allocable under the terms of federal and DOE acquisition regulations. And I have a FAR part reference there if you need further information. There is an opportunity to identify both proprietary and restricted data within your proposal. It's important that offers are specific and thoughtful about the data that they're identifying as proprietary or restricted. Things we wouldn't want to see are like saying that the entire proposal itself is proprietary, or anything that is publicly available or widely known would not be considered proprietary. So it's important to be specific about that, because it just makes the legal process go a little smoother. You'll also need to provide acceptance to the statement of work, NREL's terms and conditions, both general and IP, or request exceptions to those. And then the forms that are required are price cost proposal form, organizational conflict of interest. There's one, you'll complete one of two depending on your organization's circumstances. New vendors need to complete a W-9 and a ACH banking information form, and then NREL's representations and certifications form. And this is also where you will certify if you are registered in SAM.gov, which is the system for award management. I like to point that out just because it can be a timely process. So if you do plan to submit a proposal, I recommend that you try to get registered sooner than later so that it doesn't delay things down the road. Next slide. This is the payment schedule I had referenced before. So because these are firm fixed price subcontracts, subcontractors are paid based on completed deliverables. So part of your proposal submission will include a table that looks similar to this, where you'll list all the deliverables in the statement of work, and you'll assign a value of how much you believe that deliverable is worth based on the effort that you plan to put into it. And within that, you will show both the NREL portion for that deliverable as well as the subcontractor portion. And this is going back to the price participation minimum, which around 20%, maybe as an example. This is where you'll demonstrate that you are meeting that minimum. With regard to property or equipment on the effort, and we're defining this for this purpose as anything that has a useful life or value after the completion of effort. So ownership of property or equipment is determined based on who is paying for the item, whether it's NREL or if it's included in your price participation. So generally, at the end of these efforts, NREL isn't necessarily interested in retaining ownership of something that might have been bought or something that might have been built during the effort. But if NREL is paying for it, they have the rights to retain ownership of it. So if you have property in your proposal that you plan to retain ownership of after the effort is complete, it's important that you include that as your price participation so that you are the rightful owner when everything is completed. And lastly, I just wanted to touch on invoicing, which is obviously after an award is made. This just goes back to the payment schedule. You'll invoice based on what you've laid out in that deliverable payment schedule above. And those will be based on approved deliverables, and you'll submit those to our AP department. And I believe that is all that I have planned. Are there any questions for me on procurement or the RFP process?
Hello, Kyndall, this is Luis. Yes, I have a question for you.
Okay.
So you're treating this process as an RFP, but you're actually, as the NREL, you're not buying the rights of the project. Is that right? It seems like, because I have been participating in quite some, RFPs, and every time that I participate is for a service, but this is for granting an award. But it's you're treating the process as an RFP, but you're not actually buying the project. Is that right?
It is treated as an RFP, but I guess anything that is developed under the subcontract, NREL is paying for. So we would, I guess in that sense, be buying whatever is developed.
And you would retain the rights for exploitation of the technology?
NREL would have rights to anything that's developed that we're paying for.
Okay.
Yeah, this is an issue that comes up quite frequently. So conceptually, NREL retains the rights, which it's not really NREL, it's DOE retains the rights.
Okay,
DOE or
Energy
NREL
then.
has never exercised those rights, and it's language that is written in, and I'm not a lawyer, so but in the discussions, DOE has the ability to do it under extreme circumstances. It doesn't exercise that right.
Mhm.
And there is a process that if people are worried about it, you can apply for exemption to DOE's right. But no one's ever had to do that. So if you have concerns over this, Luis, I would encourage you to check in with a couple of other former CIP awardees to talk through this IP issue, because if you wrap yourself around the axle, then yeah, it seems like by taking an award from DOE, you're giving all of the rights to all of your innovations to DOE. And that's certainly not the intent, and DOE has no intent to commercialize any of this stuff. We're here to help you develop your technology. But if you read the legalese, and if you get a lawyer to read it, they're going to say, yeah, you're signing off all your capability to the government.
Well, it makes sense. Again, I'm just, kind of asking Ian, because it's in Ian, sorry, because it makes sense, because you're treating it as an RFP, and normally when the government or a company or private entity submits an RFP or issues an RFP for, someone to submit the response, is to buy something. So just the term of RFP, in my mind is like, okay, they're trying to buy something. And that's why it was the question. For me, it's okay, because you're financing some projects and it makes sense. This is taxpayer money, right? So it needs to be, at least they have to do, the NREL or DOE needs to retain some kind of rights. But, this is, in our case, this is a technology that it can be a game changer. Again, we haven't had time to discuss it, and we're still in a very early stage, but it seems like for whatever we have done, it's a game changer. But these are the questions that typically still our lawyers will look at them, and it's fine. I'm just asking.
Yep. No, certainly. And getting back to one of Kyndall's points, that's one reason that it's really important in your proposal, once you get to that point, to highlight what you consider intellectual property. And so the introductory paragraph is not intellectual property, but once you get into the more details of it, you do want to specify that this is protected information and you treat it as such.
Yeah, because in our case, we already have patented technologies. So, it comes into conflict because, we have the rights to retain it, and we would have to do some legal stuff to do so. But yeah, I'm sorry for interrupting, but yeah.
No. Perfect. Yeah.
Good question.
Hopefully we've answered that.
A couple in the chat here.
Yep. Go for it.
Okay. Heather Rose Weaver wants to know, Kyndall, do you anticipate any changes to the forms this year from last year's RFP?
Not that I am currently aware of, but I don't believe so. Is there a specific form? The main one that we really can't change is the reps and certs is what it is. As far as the price cost proposal or the trying to think what else it was, like the deliverable payment schedule, those can be, you can use your own form as long as it's a similar format to what NREL is asking for. But as far as our standard forms, I don't anticipate any big changes between now and then.
Great, thank you, Kyndall. Let me grab Tim's question real quick, and then I'll go to you, Paul. Tim Olson wants to be clear, can materials potentially be covered under NREL's portion of the cost participation and thus owned by NREL/DOE?
Okay, can materials potentially be covered? So if NREL is paying for something, we legally, technically have the rights to retain ownership. If it's consumables, when you say materials, I don't know if that means consumables. That would be something that we would consider not to have a useful life or value at the end of an effort. Again, it kind of needs to meet that standard. So NREL can pay for that and it wouldn't have an issue as far as ownership. But if we're paying for property, property or equipment, then yes. If we pay for it, then we have the legal right to retain ownership.
Right. Is that clear, Tim? Okay, if it's not, let us know.
Yes, thank you.
Okay.
Great. Thank you, Kyndall. All
Mhm.
right, Paul, what do you have for us?
Yeah, well, actually, I think my question was along the same lines as Tim's. That has to do with, I wonder if you could elaborate a little bit, Kyndall or Brent, or on, so if we, as developing a prototype or a working component, that did I understand you to say that all of that cost could be for building and constructing that could be taken as the subcontractor's cost share toward the project, and therefore the subcontractor would retain ownership and then forego the complexity or the dealing with who owns it, that if NREL owns it but doesn't want it, dealing with how do we change the ownership to somebody else kind of thing. Would it be appropriate, I guess I'm sort of asking, maybe if we would put equipment that we're developing, designing and building, design verifying, but then perhaps we want to let one of our supporters for the project use that equipment in turn. Could we identify that as 100% of a segment of our cost share in the proposal? Does that make sense?
So you're saying that that the property or whatever you're developing, that you would have that as your cost share? You cover it 100% in your cost share?
Yeah, I guess I'm asking did I hear you say that? I was thinking I heard you say that we could do that. Yeah, so if we would segment.
Yes. So
Yeah.
if you cover it, you absolutely can retain ownership and you can do with it, whether you keep it or you give it to someone else. That's completely fine with NREL.
So maybe another way to say that would be, you can if you have, a budget developed with line by line items on it,
Mhm.
and one of those items is $50,000 to build some electronic equipment that we design it. The design would be cost shared, but then also if we build it, we could identify that, okay, we're going to pay for all of that. That is, the subcontractor is going to pay for all that line item.
And we had this come up with one of our awards this round, and we really had to break down what it costs to build something. So like the labor that would entail to build something, that would not need to be included as your cost share. NREL is happy to pay for that. Anything consumable, NREL can pay for that, but it's like the hardware, substantial tangible items, I guess, that have value at the end of the effort is what needs to be covered by the cost share. But Ian is.
Yeah. So I think, no, exactly. The answer is yes, Paul. The way you want to do it is to break that out. And Kyndall showed us the kind of the schedule for different things for each of the deliverables.
Yeah.
There's nothing that says that each one of those deliverables has to have a 20% cost share or whatever the cost share is. The total
Okay.
has to be. So if
Okay,
for the first report, well, that's mostly NREL, and
Yeah.
in your case, Windurance's cost share is 2%. But in the construction of the prototype unit, the Windurance cost share is 80%, and NREL's, I'm making the numbers up, obviously, but Windurance is 80%, and we're paying for the engineering services around that, and you're paying for the hardware. Then it's clear the hardware is yours, and you can do whatever you want with it after the hardware. Another thing to think about is that if some of that hardware is expendable, okay, it's a prototype. So it's not something, after you prototype test it, it's not something that is going to have a useful life, because it's a prototype, and you're going to build another unit afterwards that, and so the prototype doesn't have any value. We're not going to want it, a piece of prototype hardware that you've tested and now have changed. That
Yeah.
type of stuff we can cover. So if you think about it from a wind turbine perspective, the tower of a prototype turbine you could use, all right? And so that has
Right.
value. The blades of a prototype turbine that are never going to be used again because they're prototype blades, we cover that price. And if we wanted the blades, we would ask you to give it to us, but we're not going to want the blades, and we're not going to ask you to give it to us. So just as you go through the proposal, think about what things you're going to want to have at the end of it, and you're going to want to retain ownership of, and make sure that that is covered in your cost participation, whether it's 20% or 50% or whatever the number happens to be within the proposal framework.
So we would have to, let's see if I'm thinking about this right. Okay. I guess the main thing is the net cost share has to meet the minimum requirement, meet or exceed the requirement, but the line by line, we're flexible to do however we want.
Yeah.
And that could, and depending on how that's done, that would govern the ownership of any property, material property that would be created out of the project.
Exactly.
Okay. Thank you. That helps me.
Okay.
Cool. Thank you, Paul. And we'll go to James Truslow next. But Sam, you might want to think about verbalizing your national security question next, because I'm not sure I understand it in the chat. You go next, James.
Thank you, Jim Truslow, CBC Wind. Yes, I have two questions. The first one follows the last speaker or questioner. And that is, I recall reading somewhere, and I can't remember where it was in last year's package, that when you do submit the equipment that you're developed or have developed as part of your price participation, at least one of the categories, and it may apply to all of the categories, the costs for that development of that equipment have to be incurred after the contract is awarded.
Okay.
Is that true? I mean, this is a follow-up to a question I had on day one, is if I have a prototype already and I'm applying for the installation and prototype testing, my question is, can I take that prototype that I already have, which has value, and include it as my portion of the participation?
So I'm trying to think if we include, I want to say that it should be costs for the effort specifically. So not something that is pre-built, unless Ian, we've had awards where that's different, but I think
Yeah, I'm pretty sure we have done that. We have a lot of people.
There's a way to get around this. Like, for instance, Windward Engineering has a lot of equipment that they provide and they lease to the project. And
Very clever. I like that. That's very clever.
that makes sense.
that avoids all of those issues.
Okay.
Thank you, Robert.
That's incredibly useful. Thank you. And the second follow-up question I have, which is unrelated. So we've received grant funds from the state in which we're located to build the original prototype. If is it possible to when you're listing out your price participation elements, to list grants that you're in the process of applying for when you submit the application, even though the grants haven't been received yet?
I have not had that come up before. So you would list money that you have incoming as your price participation?
Yes.
Okay.
So because, you know, these things, they have their own tracks, just like you have your track. And there's a good chance that by the time you get to at least the initial stage of the decision making, we may already know that we do have a commitment for the state grant.
Okay. I guess I'm not sure that it's of interest to NREL to know where the money is coming from. If it's coming directly from you or if it's coming from another grant that you're getting. I think what's important to NREL is just that you're meeting that minimum. But I haven't had that come up before. So I can check with my manager and I can relay the information back to Ian and Brent and have them get back to you on that. That's my initial thought.
Great, that's fantastic.
Okay.
And we certainly have a lot of grantees in their proposal specify that they have grants to do some of the work pending or in process and things of that nature. So that's very common to articulate within your proposal. Elements that are incoming.
Fantastic. Thank you very much. That was great.
Thanks.
Thank you, Jim, and Kyndall and Ian and Robert for answering. Tim, you had a question about national security and if the legalese has some restrictions around national security and the DOE ownership of some of the IP, I think. If you want to clarify, Tim, you can go off.
I'll jump in here, and I don't mind if you say throw that to the lawyers later.
Right.
Of course, as a bidder, I want minimal restrictions on what I can do. As a taxpayer, I don't want our brilliant work running off to an overseas, firm to then compete against our company's product lines. So that's especially with the national security, not so much maybe for our stuff, but certainly national ownership of our technology is the interest.
Right.
Is that protected somewhat somehow?
So conceptually, it could be, and I think that is the interest. Though generally speaking, I think the language, as I understand it, that was originally proposed or that's included in DOE is more the other way around. So if DOE helps develop a technology, and then there's a national security reason to use that technology, we don't have to rely on the company to give us permission to use the technology, not to stop them of transferring that technology to other companies or to other countries if the company is purchased by a foreign entity. We've had some cases around that. Northern Power is the most kind of obvious example because now it's owned by an Italian firm. But that's never been exercised on our part. And there hasn't been any real discussions about within CIP whether we could or would choose to do that.
Okay, thank you.
Yeah, thanks, Tim. All right, Paul and Jim can put their hands down. I don't see any more in the chat, so I think we'll move on to our next session. Thank you so much, Kyndall. That was very invaluable.
Yes, you're welcome. Thank you.
And just Kyndall's email is in the documentation. Yes. And so if you have any further questions, I mean, certainly don't hesitate to include Brent or myself on them. But if they're kind of contractual in nature, we're going to bring Kyndall in anyway. So don't hesitate to email to her.
Yes. And also, if you want to be on the list of interested vendors and you're not already, you can email me and I'll get you added.
Great. Right. Thank you, Kyndall.
Thank you.
Okay, our next session it covers the design review, design evaluations and what is expected, designing to meet the standards for certification, and maybe we'll have a discussion about consultants and go or no-go decisions. All right, and our speaker is Brent Summerville, that's me. And so using some information here, originally from Rick Damiani, former NRELian, and then Robert Preuss, former NRELian, now consultant. Both of these guys are now acting as consultants, so I'm glad they're staying in our industry. So there are quite a few topic areas that require some sort of design evaluation or design review. And those include the prototype design development, prototype testing, small turbine certification or listing, and/or type certification and listing, and the newest topic area, prototype manufacture and installation. So for the prototype design development, there is a concept design evaluation. This is a technical design evaluation directed by NREL, and we'll use NREL experts or other DOE lab experts as appropriate for the particular project. And the design evaluation will include a detailed technical review with the experts, and the subcontractor will make a presentation describing the various technical concepts that we'll go over today, performance estimations, cost estimations, and have a back and forth with the team. And the intent of this evaluation, which happens fairly early on in the effort, is to ensure that this prototype design, this turbine or component, is ready to progress to production design. Or at least that it is potentially technically and commercially viable. It is expected that technical problems and challenges will be identified during this evaluation, and they'll be addressed during the next stage of development. As long as the challenges identified in the design evaluation appear to be solvable, the concept is otherwise viable, then the project can be approved to continue. And so this does serve as a go, no-go decision. And NREL has offered both goes and no-goes after these design evaluations of prototypes. We will talk a little more about this tomorrow during that topic area session. Prototype testing means you have a prototype developed and you're ready to test it. So again, there's a design evaluation, again, directed by NREL using experts in-house or other labs. And we'll similarly review the technical concepts of the turbine, performance estimations, and something new in this topic area, testing efforts to be undertaken during the prototype testing, cost, and some Q&A. And the intent of this review is to ensure the turbine will benefit from prototype testing in its current configuration and will be subsequently positioned for certification testing and eventual certification. So if it looks promising and we think it's ready for testing, then it'll get a go. If the no-go decision is made, then the effort could end early. And there's a Pika Puffin prototype. For small turbine certification or listing, the intent is to ensure that the turbine to be tested is likely to pass the structural design review as part of certification. It's likely to be certified. It's a design that the team decides is likely to be certified if the field testing is completed successfully. And so this is it's beneficial for all. As a former certification body technical director, it's pretty great to have a practice round of a design evaluation with NREL engineers. When the design reports do make it to the certification body, they've been pre-evaluated and are in much better shape than one that's coming in as a first look. So this is essentially a preliminary version of the -2 limit state analysis, which we'll look at some details of here. Based on the design review, NREL gives it a go, no go, whether or not it's ready for certification testing. So keep in mind that this is not the design review for certification. You'll still need to provide the reports to the certification body for them to do their own design evaluation, involving checking the manufacturing process, confirming that the assumptions and inputs match what was experienced in the testing for if you used simplified loads method, checking validation efforts of the inelastic model. And for listing of, say, an inverter or component, the design evaluation for this topic area consists of a review of the equipment being listed and the documentation required by the NREL. So if you're working with Intertech or UL, then we're looking at the documents between the subcontractor and the NRTL. For larger turbines or turbines seeking type certification to the -1 standard, you get 2 go, no go decisions. So this task is comprised of a design basis evaluation and a design evaluation, which are described in IECRE operational document 501, which you can find and peruse at that link. The evaluations are conducted by the certifying body in this case, not by NREL. And NREL will make a go, no go decision based on the design basis evaluation from the certification body, and then another go, no go based on the completion of the final design evaluation by the certification body. And so you need the certification body will need to provide the conformity statements for both of those evaluations to your technical monitor. For prototype, manufacture, and install, there's a design evaluation with NREL, including all the information you've seen before. In this case, the go, no go decision is there based on, is the turbine in its current configuration mature enough designed for certification testing and manufacturing production, and it meets all the market requirements to be competitive. So is it ready? Does it make sense to move forward based on the current design? Okay, so you can see what we're up to here. There's a template here provided for design analysis report. And this will be handy when you get to the stage of your development. The basic outline, the system description, control and protection system, the modeling approach that you use to design the turbine, as you know, referring back to Rick Damiani's presentation yesterday. Modal analysis on the dynamic behavior of the system, the design load cases, the load results for each component, and then the structural analysis for all the major components in the system, including the blade, the hub, and all the way down to the foundation in some cases, depending on what standard you're certifying to. O&M provisions, transportation and installation provisions, manufacturing process, safety and function, and emergency procedures, and then a conclusion with summary tables, safety margins, utilization, and some appendices of other information like your manual and tower descriptions. So that'll help you get started. That's as good as a template as you're going to get, I think. And expanding on some of these, we really want to understand the control system. What are the operating modes of the turbine? The fail-safe redundancy of the protection system. I popped in a clip of a portion of the -2 standard up here that says the protection system shall be designed to be fail-safe. And as a certification body, as a design review, really looking for that word shall. It's a must. It shall be able to protect the small wind turbine from any single failure or fault in a power source or in any non-safe life component within the control and protection system. So it really is recommended to perform a failure mode and effects analysis to verify that this one thing fails, it runs away and possibly exceeds maximum rotor speed as outlined in the design assumptions. So it's pretty important to avoid unsafe conditions. The software and hardware for the controls, any condition monitoring of the system, and a test plan for safety and function testing. So that goes in there. On the design load cases, you really have to understand your particular design and all of the wind or turbine fault conditions to explore. In some cases, there are some unique design load cases for your turbine to study. And you list all the assumptions and the parameters for the components like the CL and CD curves and the yaw rates and assumptions that have to go into the design calculations. And some clear commentary with references to any assumptions made. And of course, a description of your modeling. You've got the 3 choices we explored yesterday: simplified loads, aeroelastic modeling through simulation, or full-scale load measurements. And Rick went into much detail about all the different types of loads to consider: aerodynamic, inertial, vibration, seismic, gravity, yaw, furling, grid faults, and whatnot. And there's some load cases on transportation and other conditions. And provide clear and organized table of the design load cases that were analyzed. And as you can see in the table, what the standards provide you are the minimum set of design load cases. And so you certainly have to assess the loads in all these states, but your design may have a particular design load case to check out. What if these brake pads overheat? What's going to happen? So you want to include a table of simultaneous. So Rick explored this yesterday, but the table of simultaneous load component loads in terms of ultimate loads and fatigue loads with the partial safety factors applied according to what's dictated in the standards, so that you can articulate the loads, design load cases that are design drivers for that particular component. Okay. So amazing tools you have to simulate your wind turbine out there in the wind through 50 years of extremes, things you can't test for, you can simulate. I remember getting into this business early on and realizing that Windward Engineering had built many prototypes of the 5 kilowatt S series in the computer and optimized and changed it and had it run away and all sorts of fun things before a single physical prototype was built. So I really encourage you to utilize some of these modern tools that have been developed over the years, even though they're a bit daunting, but you can get help. Okay, on the dynamics, you may remember our duration test eliminated the need for the observation of dynamic behavior because it was not very valuable. People watched it in various conditions and saw some things, but what is more invaluable is to generate Campbell diagrams so you can do a modal assessment and ensure that you're going to avoid, your turbine will avoid dangerous resonance and unsafe conditions. And so you've got to check all these components for not only modal characteristics, but strength. And ACP 101 lists the major components of the blade, the blade root, hub connection, the hub, the main shaft, bearings, and yaw shaft if it's a hot connection to the tower, and then the critical safety and function, protection and safety systems, and the nacelle frame. Pretty much all things are checked, all components are checked according to the IEC standards. And of course, you're checking for ultimate fatigue and service limit states for those components based on the loads you estimated. And there's a summary of the components and relevant. So for each component, you're checking all of this, the frequency, the dynamics through the eigen analysis, the finite element analysis of the major components. At a minimum, looking for equivalent static loading, explanation of adopted boundary conditions, load distributions, material properties, the safety factors, the manufacturing process, and which standards were used for that particular component. For the blades, 101-1 is only requiring a static load test for component testing. And what format does NREL want to see your design details? Well, it's a little clumsy to just go through the report. So it's very helpful to summarize your design report into a PowerPoint presentation so we can go through all these major inputs and outputs and assumptions and findings and in this format. It really facilitates a smoother design evaluation process. And think of it as a benefit. It's you're able to review your design with some experts that have seen all sorts of things in the industry, ask questions, provide feedback, and you'll go away with some beneficial feedback. If it's just not possible to move forward, that can happen, but typically what happens is you move forward with some good input and you have a better design out the other end. So some takeaways, can't rely on just this presentation, although Rick and Robert and have put a lot of good stuff in here. You really need to read and reread and understand the standards, and or find someone as a consultant who can help you there. You have to be scientifically rigorous and convince the reviewers of the choices made and prove that those choices will result in a safe and reliable design. Pay attention to the documentation format, version control, figures, keep it tidy. Use your best engineering judgment. Be prepared to be asked for more clarification, possibly some tests and proof of your assumptions and design. And recall that this is required. These things are required for a go no go decision on some important topics such as certification. Okay, well, so thanks to all the standards making experts out there. I've been involved in some of this throughout the years, and if it's not clear, we're all trying to follow the standards. The test site is testing per the standards. You're designing per the standards. The certification body is doing conformity assessment on all that according to the standards. The standards are written as clear as possible. And if they're written well, they can be a tool. If there's written poorly, they can be a barrier. So think about participating in standards development because that's where all the rules are. It's not always clear, and that's why we have certification bodies to help make decisions in those gray areas for certification. Okay. Any questions on that topic? And while you're thinking about that, I'll say that the next topic is just some last details on CIP, including tech support opportunities, deliverables, outreach materials, and the levelized cost of energy tool. We're right on time, but just checking for one more go at any questions while I transition to the next one. Our first speaker in the next session will be Scott Dana. You guys okay out there? Did I kill you? All right. Can someone say something just so I know that you're alive?
We're live.
Okay, thank you so much.
We're here. We're with
After seeing Ian poof disappear on Tuesday, I was a little paranoid there. Okay, I don't see anything in the chat nor any hands raised, so everyone is copacetic on design evaluations, and you're ready to hear Scott Dana's voice. It's Scott, are you here?
I am here. Can you hear me?
Yep.
Excellent.
All right, Scott Dana is one of our engineers at NREL. He serves as a technical monitor on the CIP projects, and he's going to tell us about opportunities for tech support with NREL. Thanks, Scott.
No problem. You give me a click there to advance the slide.
There you go.
Excellent. Okay. Yeah. So within CIP, there is opportunity for some technical assistance facilitated by NREL. It can vary quite widely. I believe I'll finish with a more thorough list, maybe not totally inclusive, but it will give you a good idea. Starting here, we're looking at some of the structural testing capabilities at NREL. So we definitely have made quite a living and reputation doing structural testing of wind turbine components of all kinds, blade testing, as well as tower testing. Certainly in the small wind space, small towers will fit in our facilities. We have several different high bay facilities, fully equipped with bridge cranes. We can do a lot of heavy material handling. Things like that are absolutely routine. We do have ability to make measurements, force displacement type measurements, static testing, fatigue testing, so we can do accelerated lifetime fatigue testing, for example. We also have a lot of non-destructive capabilities with modal testing, acoustic emission. We do even have a digital image correlation system, so we can set that up and actually measure full strain fields across a component. I think that covers everything on that slide. Advance for me, please, there.
There you go.
Okay, yeah, and then dynamometer. We do have a dedicated smaller dynamometer facility. It's a 225 kilowatt motor. It's 300 horsepower, variable speed, and we're actually kind of in the process now of procuring a new gearbox that will allow for multiple different configurations. So we can provide variable torque and speed curves depending on what your test specification might be. So that's something that is a good fit for a lot of turbines in the distributed wind space. We also have some larger facilities, a 2.5 megawatt dynamometer. Might be a little overkill for some machines, but again, depending on that torque speed requirement, it could be a fit. Next, please. Yeah, and then grid testing. We do have a lot of grid and electrical testing capability, both at the Flatirons campus where I'm located and down at our main campus in the electrical testing facility down there. So we can provide some pretty unique capability of actually creating our own grid and simulating, well, not even really simulating, I mean, actually creating different grid events and determining how your power electronics and your turbine might ride through those different events. So one is the controllable grid interface, and then CGI, and well, actually there's two. There's a new project coming online called DIAL, the Distributed Energy Integration Laboratory, or did I get that right? I'll look at it. Okay.
DIEL, DIAL, yeah.
That's right, DIEL, yeah. And so that also has grid capabilities, controllable grid capabilities. Yeah, and then you see in that picture, there's some solar as well. We can definitely handle like hybrid type testing capabilities if you're looking to do kind of a wind solar hybrid system. Yeah, I think this is kind of wrapping up. Yeah, so so first thing is we really prefer that you consider what the private sector might have to offer. You know, what's out in industry, other you know, test bodies before engaging with NREL. We don't want to compete with the private sector, but if there's you know, a compelling reason such as timing or cost, you know, maybe we can engage in a technical opportunity. There is a list there, but before we kind of run through that, I don't want to forget. So within CIP, tech support really kind of has two flavors. There's the more low effort where we, you know, we're talking like a handful of hours, like maybe 4 or 8 hours to do some kind of a review, maybe of, like, for instance, we've done some reviews of aeroelastic predictions where, you know, we had an awardee that really had some doubts about if the predictions were realistic or if there were some shortcomings. So that was one of the technical capability areas where we were able to get some of our aeroelastic experts, and they could, you know, just spend a handful of hours reviewing, providing feedback. And similarly, we've done things with controls. So Rosco is an open source controller developed by NREL, and we've had awardees leverage that control capability. But again, it can be a challenge to optimize those things. So through CIP, we were able to offer technical support to ensure that, you know, they were setting up and tuning the controller correctly. So that's kind of the lower tier technical support effort, where we can pretty much approve that right away and move on it. And then there is a more involved technical support option where we're looking at lots of hours, tens of hours, maybe hundreds of hours, and tens of thousands of dollars. And that's where we really need to craft you know, a detailed scope of work. We need to look at the timing and the facilities that might be used, the personnel that would be required, and then develop a plan, take that to DOE, and then, you know, hopefully receive approval to move forward with that. And some of those types of efforts are where we're using the actual facilities here, like the dynamometer, for instance, or maybe one of the structural testing laboratories. So that's a little idea of, you know, those two tiers of support. So know that the first tier we can implement pretty quickly. The second one, it does take some time and planning and development, and it takes approval, and approval is not guaranteed. There's only, you know, so much funding available in CIP for technical assistance. and we can't always support every request that comes through. So running down that list, I think we've covered a few of these: design review, or reviewing maybe some aeroelastic modeling, structural analysis. We are very well versed in standards around here. So, and I know it can be a little bit ambiguous. I mean, I think even Dean Davis was saying that the other day about acoustics. Oh, Ian's got his hand up. Ian, why don't you go ahead?
Oh, just really quickly, and sorry to interrupt. I was going to.
Yeah, no problem.
So the idea of these kind of larger projects, like blade testing, and we see a picture here of a blade that we're testing under a CIP project. It is very useful, and in the application, at least historically, in the proposal that you write, there is a place there where we ask for you to identify projects where you would like our technical support. So as an example, if you're proposing something to us like a component improvement and you want us to test a blade, it makes the most sense. You're going to have wanted to go out and find out how much it's going to cost to test that blade commercially, because you're going to want to include that in your CIP proposal. If you can't get anybody to do that blade test, and you say you want NREL to do that blade test for you, or Sandia, or some other laboratory, so I don't want to be restrictive to NREL. You want Idaho National Laboratory to test a microgrid controller for you that you're designing, as another example. Include that in your proposal, and include the budget that you had gotten from other people to do it. Or if you want to talk to someone at NREL about what it might cost, like Scott Hughes here, that's fine to reach out and talk to people within the laboratory to find out what it might cost to do that. But include that in your proposal, so that we know that to be successful in your component improvement project for your new blade design, you would like to have $150,000 of NREL testing to make that successful. And the project won't be successful unless you get that, and you have talked to industry about trying to get it done by some other entity, and for whatever reason they are not able, can't, or they will do it, but they'll charge you $5 million to do it, whatever that happens to be. So if you include that in your proposal, then we know that up front, and we can reserve funds from the beginning. And so I encourage people to do that. Sorry, that was a little bit long-winded, Scott.
No, that's a really good distinction to make, because there is an option early on in the proposal stage to let us know what you're thinking for tech support. It doesn't mean that it has to be there, but that is definitely most helpful for us. And it looks like we've got another hand up. I think I've pretty much wrapped up the list here anyway, so let's just open it up for questions.
Well, Scott, this is Luis, and I was raising my hand.
Yeah.
Before.
Yes, so please go ahead.
Here's it seems like your testing facilities are kind of designed for traditional windmills, right?
But no, not necessarily.
All right. So you're kind of capable of testing disruptive technologies or new technologies that not necessarily use the big blades, but
yeah,
instead,
I mean,
we
routinely do design experiment for just about anything that you can think of. So it's definitely not a limitation to the prototypical, you might say, wind turbine. No, not at all.
That's okay. That's great news. Again, because our designs are not kind of like traditional. So I was wondering. Here's a second question for you. So you have wind tunnel capabilities? You have a wind tunnel there?
No, there's no wind tunnel here. Our wind tunnel is Mother Nature. We have 300 test site where we routinely experience extreme wind events. Yesterday we were.
I saw it on the news. Yeah,
exceeding 90-mile-per-hour wind gusts at ground level. So that's our wind tunnel.
Yeah, again, but there are options in the private sector, right?
Yes, right, exactly. Many options.
Thank you so much. Thank you.
Yeah, of course.
Yeah, thanks, Luis. Luis, And nothing else in the chat, no other hands. So thank you so much, Scott, for that
Yep.
presentation. Very good.
Yep.
And it is the DIEL. Okay, Distributed Integrated Energy Laboratory.
There you go.
Sorry about that.
Down there at the bottom.
Yeah, there it is.
Ah, there it is. I knew we'd get
There-
to it.
There it is. All right, thanks again.
Of course.
Thank you, Rick. All right, we'll move to the next thing here, which is just an overview of deliverables and outreach materials. So similar to what Kyndall showed, well, you'll approve, your project will be an assemblage of deliverables. And when you work on a deliverable, you send it in to your technical monitor that is assigned to your project. There's some review back and forth and approval of the deliverable, at which point you can invoice for the value, the agreed upon value of that deliverable, and you're paid for it. And so that's how things work once the project is executed. You'll have a set of deliverables throughout the span of the project. The first being a summary of work effort due after 1 month, and then quarterly reports throughout the project period, and then deliverables specific to your project and specific to your particular topic area. And so that's our sort of number one project management tool. And we communicate regularly via these quarterly reports, and also with check-ins that are typically done monthly, so that everyone's on the same page and there's a good steady stream of communication. Some deliverables, such as designing something, building a prototype, can be quite large and have high values. So there is an option. You can negotiate sub components of a complex deliverable, and in other words, break it up in A and B parts, for instance, resulting in more occurrences here, but also providing more opportunities for regular payments throughout the duration of the project period. And of course, the clock starts on the occurrences which are due based on months following the contract execution. So the clock starts after the contract is executed. Okay. And the Department of Energy and the National Renewable Energy Laboratory use a number of methods to distribute information on CIP projects to the public, including press releases and fact sheets, articles, some highlighted success stories, accomplishment reports that go into the Department of Energy from NREL, and other announcements from the DOE. And do note that materials that are not for public dissemination include subcontractor project reports and any material marked as confidential or proprietary. The primary or the earliest generated outreach material is probably the project fact sheet, and other ways to highlight the project. All that information comes from that first deliverable, the summary of work effort, where it's really basic description of the project, the funding levels, the goals, the methods, the partners, the benefits of the project, what you're doing, and some photos of the process or the wind turbine. And so these will be generated, and typically the technical monitor will send these draft materials to you, the subcontractor, for review and edit to ensure that it's void of any errors or accidentally includes proprietary information before it is made public. But we are, I've only been here a year, but I see an uptake and some efforts to make everyone a little more aware of what's going on with these really exciting projects that have some meaningful impacts. This next section is regarding the levelized cost of energy tool that comes with the RFP when it is released. You'll receive two things with the RFP. One is a cost of energy instruction document, so that we're all calculating the levelized cost of energy in the same way, and the accompanying spreadsheet, which is a useful tool in performing these calculations. So we'll just go through these procedures at a high level, but all the good details lie in the instructions and accompanying spreadsheet. So levelized costs of energy is the lifetime cost of electricity from the distributed wind system. On the top is all the money, and on the bottom are all the kilowatt hours for the lifetime of the system. The installed capital cost, well, back up, the FCR, the fixed charge rate, is provided in the tool with a default of 7.4%. The installed capital cost is supplied by you, which is the capital cost to the customer. AOE, annual operating expenses, includes the levelized operations and maintenance costs and the levelized replacement cost for any replacement parts. And so that's all dollars, including capital investment in the installation and ongoing cost of operations maintenance. And on the bottom is the AEP, annual energy production, which is calculated in the tool as well for your particular systems, and it does include some losses or deductions. So for the turbine system cost, the basic outline or layout of this spreadsheet is the baseline, proposed, and end of project columns. So baseline are the current costs before the proposed project effort happens. And so the proposed column is the expected cost after the effort is over. So these two columns are filled out in the beginning of the project in the proposal stage. You hang on to this spreadsheet until the end of the project, where you fill in end of project numbers on the actuals realized at the end of the effort. And so don't fill that out at the proposal stage. In general, the green fields in the spreadsheet are for you to manipulate and provide input, and all the other calculation fields are white and should be left alone and are generally protected from that change, from changing. But some of the baseline assumptions and defaults can be changed, and we'll talk about that next. For the installed cost of the system, we realize that there is some variation in installations, but you want to try to include everything expected in a typical or normal installation billing. You use the baseline or current cost and the expected improvements to justify the improvements in LCOE that you are proposing. In some cases, that is removing cost through an optimization of the system or a component. In other cases, you're increasing performance. And that could be you're increasing performance at a higher cost, but the resulting increase in annual energy production may still provide a lower levelized cost of energy at the end of the effort. And yes, we will sort of do a reality check on the reported installed costs based on available data to NREL from a sample of real world installed costs. And the inputs here are very detailed. So between the spreadsheet and the instructions, you should be able to itemize the installed costs and then use the other fields down here to indicate the difference between your cost for, say, the foundation and the cost to the customer. So that what is the end result is the total cost of the installation for the customer. On the annual energy production calculation, it's in the spreadsheet. You, the proposer, the author of the proposal, will provide the power curve for your wind system at its hub height. And it should be a power curve either that's calculated, for a prototype or that has not received a power performance test, or measured if there has been some measurements of power. But in either case, it's a big red flag if the power curve and the resulting power coefficients exceed the maximum theoretical BEDS limit. Again, you may have a baseline power curve and a proposed power curve if you're proposing an increase in performance of the system. And again, hang on to the spreadsheet for the final calculation of LCOE or annual energy production and resulting LCOE, and try to be accurate in your deductions for availability, blade soiling controls, and grid availability as shown here in the spreadsheet. So we want everyone to calculate the AEP at a 30-meter annual average wind speed of 6 meters per second for comparison purposes. And as you can see, the spreadsheet will shear that 30-meter wind speed at 6 meters per second to your hub height based on an assumed wind shear exponent of 0.25. Now, as indicated here, the 6 meters per second is not locked. It is a default. We still want you to calculate this number. If you change this figure, say you're targeting sites with an average wind speed of 5 or 4 or 8 meters per second, then you can do a secondary calculation and provide a justification on why you provided an alternative calculation based on a different assumed annual average wind speed. And the same goes for wind shear exponent. For O&M, we want to try to capture the most realistic O&M costs throughout the lifetime of the system. And for example, if the manual calls for an annual maintenance, then the cost for annual O&M should not be zero. Assume there will be some downtime, and if there are expected replacements, say in 10 years, then that replacement cost goes into a special field in the spreadsheet, different from the annual O&M cost. And so if there is something that is expected to be replaced periodically during the turbine design life, but not consumables such as brake pads or oil, then you enter its cost into the replacement cost field, and the spreadsheet will levelize those costs as a mean or an annual cost contributor to operations and maintenance. Okay, so that's it. Between the instructions and the spreadsheet, you should have all the information needed to do an accurate LCOE calculation, enabling the reviewers to compare LCOE across applicants. And again, if you make any changes to the defaults, we need to see some detailed explanations of why. Thank you very much.
So the last session of the day, though, I guess we have a little bit of Q&A, but the next session of the day is really to dive into a little bit more discussion about the CIP, and it's going into the future. So how can we improve CIP? And this is going to be led by Brett from the Department of Energy, who we got to hear from on the first day and has been in the background, listening in to the conversations. But really, it's an opportunity to hear from you about kind of thoughts about CIP now going into the future, and then what things we can do to support it. Brett is going to lead us off with a bit of context setting and then dive into it. And then just some housekeeping to facilitate the discussion, because we've got about 50 people on the phone. We thought about trying to do this in breakout groups, but thought that having everybody discuss here in an open forum is a better way to do that. So please feel free to add ideas to the chat, as Heather just did. So please, thank you, Heather, and please feel free to do that. Raise your hand and we will try and call on you to kind of make introduce yourself, make a quick statement or comment. And then, because in a lot of cases, if we were sitting in a room, we would kind of build on that comment and have people just chat around on some of the ideas until we had kind of exhausted that discussion and move on to another comment from somebody else. So so raise your hand, and then we'll kind of try and dialogue through that. And then we will, oh yes, raise your hand. And then we'll move on to the next comment from the next person. Okay, thank you all. And Brett, why don't you lead us off?
Sure, thanks, Ian.
And I'll stop sharing the screen so that we can see each other like we would be doing if we were actually in a room chatting. So please feel free to turn on your cameras if you would like.
Okay.
Go ahead. Sorry, Brett.
Yeah, no worries. So yeah, reintroduce myself, Bret Barker. I've been supporting the management of the Distributed Wind Research Program at DOE in the Wind Energy Technologies Office for over 10 years now, and was one of the brains that helped conceive and develop the CIP, and have been with it throughout all those 10 years, which I may be the only person who can say that. Maybe not, Ian, you're right there, certainly. But here's the reality, folks. You know, the program started in 2012, and it's coming into its 10th cycle. And the CIP has been very successful at driving cost reductions and increasing the number of turbines tested to certification standards. And I think that's evidenced by the new technology offerings that are on the market today or are about to arrive in the near future. And so the optics are for my management that the CIP has achieved or is very close to achieving what it was originally conceived and designed to do. And that was to, shepherd in the next generation of much lower cost certified small wind technology and medium scale wind technology. And so I'm not here in front of you today to say that this is the last cycle of the CIP. But the reality is that any federal funding program that's been around as long as CIP has is going to receive a lot of scrutiny. And the perception of in perpetuity funding is not necessarily a good one. So though we have made continuous improvements to the CIP over the years, new topic areas adjusted, cost share requirements, award sizes, evaluation criteria, you name it, the NREL team, added the provision of technical assistance. Every year we try and make it better and more impactful. But it's still known as the CIP within the building, right? So I think the other thing that's at play here, apart from that, sort of having the target on your back, so to speak, is, under the new administration, there's a much stronger emphasis on deployment acceleration. And, within the available funding that we have to allocate across the distributed wind research program, we have to take that into consideration. And today the CIP is the largest single investment year over year. Now there's some exceptions to that when we've run funding opportunities, but again, under a scenario in which there's pressure for us to retire the CIP, and again, this is entirely hypothetical. I'm not trying to put the flag up, hey, this is the last cycle, this is your last shot. That's not what I'm saying. But I think it's useful for us as an industry to have a discussion here about, a scenario under which we can't run the CIP anymore. And the thing that comes to mind for me is the funding mechanism, the investments we've made with NREL that administer this program, that can all carry forward, but the focus area may need to shift a bit. So in other words, I think we have a proven model here that has demonstrated success in providing funding to and providing technical assistance to small businesses that have led to really positive results. And so I think that's something that carries forward regardless in this scenario, but we may need to shift the focus area a little bit to align with the priorities of the new administration. And again, totally hypothetical. So I noticed Heather's already chucked one idea in the chat, and installer qualification. That's certainly something that's on my mind. If the market's going to scale, is there an installer base out there to support that scaling? Similarly, manufacturing capacity and supply chain, especially with some of these incentives that are in the Build Back Better Act favoring domestic sourcing, and adders for that is another thing that's on my mind. So I kind of wanted to have an open and respectful discussion amongst everyone here about what either a future CIP under a different brand might look like, or a refocused one that allows us to say, hey, the CIP accomplished what we set out to do. We're closing the door. We're carrying the mechanism forward, and this is how we're going to leverage that mechanism. Moving into the future to address sort of the next frontier of challenges for this industry. So with that, I'll pause and pass it back to you, Ian, to see if you've got anything to add.
I mean, no, thanks. That was perfect. So encourage people to kind of raise your hands if you'd like to talk. And if people aren't raising hands, then just unmute. A dialogue with no dialogue isn't much of a dialogue.
So I can answer questions as I see them in the chat. No, Brent.
The Deployment Acceleration Program, DAP.
Yeah, but I mean, it's similar. I mean, the topic here is we need to change too, right? I mean, it's
Yeah, I understand. Yeah. Got it.
They've gotten, people upstairs have gotten a little bit of smart to just change the title, but nothing else changes. Yeah.
Well, that does bring up an interesting point, though. This is Rob Wills, that deployment, component development and improvement is part of the story. We have very, very few deployed turbines, and you're not a real product until you've got half a dozen turbines with a year of running under your belt. That's reality. And most OEMs are not companies with deep pockets that can afford to fund that themselves. So certainly REAP helps, working with the Department of Ag, but maybe that's another area of deployment that should be looked at. Thank you.
So pulling on that thread a little bit, whether it's a kind of part of CIP or part of a new kind of a new program area would be something that would focus on new deployments or deployments of new technology, and whether those are kind of prototype deployments, not like prototype, but the first dozen projects of the new Pecos wind turbine, because I don't see Pecos on my screen here, would be something that could be supported, and that might be a cost share or cost reduction or something like that to support the initial 10, as an example. Okay, thoughts on that? Considerations?
Yeah, Ian, I was just going to
Go ahead,
comment
Mike.
that, thank you. So, you know, the foundation for CIP is to reduce the cost, and certainly it was very timely with the precipitous drop in solar prices. And I think, you know, it certainly helped us to transition to a more competitive position. It has helped to fill in the gaps of size products that where we lost them. We lost OEMs due to solar pricing. So it's really helped with certification costs, which have really been a surprisingly high cost for many of us. But the other way that you can lower costs is higher production volume. And so this deployment scheme or emphasis from the new administration is very welcome. And you know, I think it's well worth considering either reducing the scope of spending on CIP, so it's maybe not the biggest program, or expanding its scope to include supporting significant applications, significant customer markets that where a little bit of co-funding will help get the pilots going, and it's got a lot of possibilities for growth. So help with the market pull, which would increase the production volumes. Particularly now that we have money going out to the agencies and federal agencies and the states and the tribes for infrastructure. There's a lot of COVID relief funding that has a runway of the next 2 or 3 years. So there's time to actually appeal to use some of that money for intervention, clean energy interventions using distributed wind. So yeah, I think the CIP has done a tremendous good, but it's well worth considering deploying some resources other places. Now, WEA is working really hard to increase the funding for distributed wind at DOE. Don't get me wrong, but we've sort of plateaued at 10 million for the last couple of years, and try as we might, we haven't been able to budge above that. Hope springs eternal, but if in a constrained budget, I think we can use some of that money more effectively.
Thanks, Mike. Just to respond to a question in the chat, and so the question is, what's the CIP annual budget? And let me start with as Mike says, the entire budget for the distributed wind research program, which encompasses a fair amount at this point, is 10 million. The last few years, CIP has been run at 3.5, give or take the year. If you want to use round numbers, at the 3 level, about 2 million of that is going out the door for awards, and 1 million of it's staying with NREL for program administration, and then part of that goes into a pot for provision of the technical assistance, right? So that also is there to benefit industry, but doesn't necessarily go out the door. It could be, lab researchers or lab facilities, which cost money that a CIP awardee might be leveraging. So hopefully that answers your question there.
I can speak a little bit about, I know there's a comment earlier with Pecos. This is Will Hersey with Pecos, by the way, and about pilot projects and everything. And it makes a lot of sense on our end because we are starting to look forward, you know, a couple of years to our first, you know, set of pilot projects. And there's like an incredible amount of value that we can show industry, you know, both from the solar side and the wind side from project financiers. And so having kind of that kind of support to bridge us through to that verification and that testing, and to make sure all the business models are sussed out could be enormously helpful in kind of transitioning to private sector support. So yeah, I just wanted to make that one comment.
Great, thanks, Will. And following on that thought a little bit, and obviously open to everybody for a response, is your thought that that would be something like buying down the purchase cost by 10% or some number? Is it working to help identify those markets so that we're covering some costs to identify those first 10 projects, so that the company doesn't have to bear those costs on the balance sheet? Is it some kind of prefabrication of parts or tooling or something of that nature, so you could actually build the 10 units or have the units so you don't have to wait for the money to come in the door before you actually can start production? Does anybody have a sense of what kind of stuff that would entail? Or what the best way to structure that would be?
Well, so, you know, let me jump in here real quick if I can. And
yeah, definitely.
My take on that would be, you know, Will or other company or whoever it may be, new technology coming to market has a pipeline of interested customers that need technical or financial assistance to actually make the project happen. So in other words, you know, a municipality could receive technical assistance or some financial assistance to procure technical support to go through the process of developing the project to help de-risk it because it's a new technology. I could see that. Mm-hmm. Like direct funding to buy down the cost of the equipment might be a little bit more difficult to weave through in terms of authorization language, but that's for us to worry about, I guess, Ian.
Yep.
Yeah, I think project development support would be huge because that's an area that's more or less outside of our competency, and so I think that's one area that we would definitely kind of benefit from support. And then I'm sure that there are areas on the technical side that I'm blanking on, but we can kind of go back as a team and think about this and get back to the group.
Are there other OEMs on the call or installers that, you know, you've got, we'll say, a dozen customers that or potential customers that are like 80% there, but you just can't quite close the deal because of that, you know, lingering doubt where yeah, Ian's hand up, okay. Where, you know, having that sort of backstop to go through the last 20 would get it to the finish line.
Yeah, commenting on that a little, especially if a CIP certification type funding went away, that would be really useful. For our customer conversations, we're kind of using like that getting to certification step as that thing that pushes them over the finish line. But if there's not funding to help a company go through that, that's really expensive. And if there's not another avenue to get that funding, you have to make a profit on turbine sales. And to get those first sales out can be a challenge. So there's a little bit of a loop where you either need units in the field or certification to get people to trust a new technology that has a really high investment cost. And you also, without certification, don't have access to the investment tax credits, which might be available. So maybe a program that gave pre-certification technologies access to a similar credit to get a first set of products out, that might be one way to do it.
Okay, so just along those lines on the topic of certification, that is something we feel really strongly about keeping support in place for turbine testing for certification. So I think when we talk about, this hypothetical scenario under which, CIP is either rebranded or, refocused on a new set of issues, I think what you're probably seeing is, the lower TRL topic areas going away. And that's the prototype, the pre-prototype, those types of things. But so then, the certification testing would be more the lowest of the TRL on the spectrum of topic areas, and then a shift towards more deployment focus. So that I know, at least in the conversations I've had with our team, like we feel really strongly about keeping the support for certification testing in place, despite whatever pressure we may get, because we do see it as just really critically important.
Hey, Brett, this is Joe Dixon here, and I'm with Ducted Wind, and we have we're kind of in that transitionary period right now, where we have, I don't know how many proposals on the table right now, and closing them is a little bit difficult. They want to see a pilot, they want this, they want that, and certification will help in some of those instances. But I think shifting some of the funds to more of a sales deployment strategy to get more turbines out there more rapidly, I think would be very, very helpful from our perspective.
Mike, to put you on the spot, because I'm doing so, obviously. I mean, you have a turbine that has units out there, but you're also looking at a bunch of kind of new innovative ways to use the technology, like your DARP, like your mini grid. Do you think something like this would still be helpful to a company that has product, but you're looking at new markets for that product, and something like this could be used for those new markets?
Right. In addition to the very good points that Will and Joe and Ian have made about how to bridge that how to de-risk the introduction of a turbine. I think that's very valuable. But I was sort of also thinking about how do you take the next step with say a utility deployment program. You've got a big potential partner. They've got 12 layers of decision making, and each one of them, the safe answer is no. If you have some cost sharing of either the setup of the project or actually more valuable the capex, then you're more likely to be able to close a pilot project that would then allow an OEM to go to much higher scale, because this is a customer that could scale. They've got the market and the financial resources. And we haven't really, this is an industry that doesn't have deep venture capital pockets. It has had them in the past. It hasn't gone well. So it would be a challenge to try to follow that route again. I think the government leveraging could really be beneficial there. So I was sort of thinking about that, and I'll throw a wrinkle in, and Brett and Ian can reinforcement. The federal government doesn't like to pay for equipment that it then doesn't own. And so if you start getting cost participation in buying the equipment, they're going to want to own it. And there's federal procurement regulations that they have to follow. Maybe congressional language that we could do, or some sort of an executive order or something might be able to loosen that up. But there are some constraints. Every time we have pushed, and we've done this for 30 years, for DOE to help with hardware costs, we run up on this obstacle. I don't know, Brett, can you put a little more color on that?
I mean, I would just say, it's not that we don't like to, it's that we can't, right? Like, if we pay for the equipment, we have to own it. That's kind of the way the language works. So that's there's not a lot we can do to get around that unless the, Congress passes a bill or authorization bill with language to change that requirement. At least that's my understanding of it.
I think that's accurate. We could be creative, like we buy the foundation or something, or we pay for the engineering and some of the civil works or something. But yes, if we buy hardware, if NREL or DOE pays for hardware, it's not your hardware, it's NREL or DOE's. I mean, it's DOE. NREL doesn't own anything. DOE owns everything that we have. So DOE owns it if DOE buys it. So we would have to be creative around that.
Yeah, I mean, my
Can I add
other,
a little bit of nuance to that?
who do we have?
Sorry, was that a?
This is Patrick Gilman.
Oh, hey, Patrick.
Great.
So just real quick on the property disposition thing, and there's, Ian, you got at this a little bit, but to the extent that we're talking about pilot projects, and particularly about things like prototype funding, we have in the past been able to make the argument that, like, the residual value of a prototype installation or a pilot is effectively zero, and in those cases the disposition is easy. So there are ways through that, and for projects that are associated with research, we can, depending on if there's a research partnership associated with the hardware, we can grant continued use of the property by whomever it is, even if we're technically the owner. So there are ways that we can get creative and work through that, that have worked in the past. But we'd have to explore those.
Yeah, so I think we can take that back and look at it. But I think the thing that I hear here that sort of sum up this thread of discussion is that pilots with partners that enable scale is something that is very much of interest here. I want to give some other folks a chance to speak. I see Ken's got his hand. Robert, were you up first? I don't remember the order, but either why don't we start with Ken and then we go to Robert, and then Rob Wills. I think you know the answer to your question, so I'm not going to address it.
Well, Robert was up first, so I'll defer to him as my previous contract manager if he wants.
No, go ahead, Ken. I'll wait.
Well, when you were asking for different potential areas for funding and listening to all the talk of the past couple of days, we're obviously a new startup, and we're working our way through technology. And there's obviously, as everybody knows, as a system, all kinds of different aspects of it. But I think when I look at, what would maybe help us, for instance, in addition to certification, obviously that's the number one, is just keeping the company going. If I was to put in a CIP for a prototype development, well, we're developing prototypes every day, right? And so that really doesn't seem to be, I'm not going to wait for a CIP return so that I can build another prototype, because that's just, I've gone through two different kinds or changes or things along that line. And maybe that would help, say, at a development to maybe install a prototype at NREL or something and work with folks there on something. But part of the challenge of a small company is to keep it going, which I'm sure Mike can talk about for years on that. But he has a well-established company now, and he's managed to keep it going. But for folks like us, right now we've got several prototypes in the field around here. We're testing them, we're monitoring them all the time, and it's really the challenge is the cost for labor and for people. And, you know, without, I think Joe just mentioned, we have interested people that are interested in buying all kinds of numbers of our turbines, but we've just kept that on hold as we work on the technology. And so to keep the company going, how do we maintain our monthly labor budget for, you know, we've got all the 6 people working on the company, but still at some point, you know, unless you get outside investors to help you, and we have had some of those. And we've also had a CIP award, which we're infinitely grateful for. But, you know, based on your burn rate, and, you know, we probably have another good year of testing or whatever, or development, something like that, that would help keep the small company going from labor would be, I think, a useful thing. Plus it creates jobs, which is great too. Anyway, just wanted to throw that out.
So sorry, could you try and summarize that in like as a topic or a bullet? Type like money for payroll, or are you talking?
Yeah, money for payroll. You know, you have to. We're kind of caught in the middle. You need to sell turbines to generate a revenue stream, but you need to get revenue to be able to come up with turbines that you can sell. So how do you balance that? And so money for payroll to keep the company going. Something along that line, I guess, you know, job pay or something like that.
Yeah. I don't know. What would you be doing with that money? I mean, like payroll to do what, right? I mean, that's
okay. So payroll, so to analyze data, work on building new components, even doing installs on different kinds of places, traveling out to see potential customers, you know, all the kind of things that we have. Well, in our company, we've got you know, a couple of guys on the business and sales end, we've got a couple engineers, and we've got a couple installers. That's pretty much how it is. Although all of us seem to do everything all the time, but it's just, how do you generate income short of getting investors to invest in you, or getting a grant or something like a CIP, without a revenue stream, which we don't have yet? How do you keep the company going long enough so you have a viable product that you can generate a revenue stream? So I guess company support for labor, I guess. Yeah. And it covers everything from it. It's mostly engineering, I would say, and data analysis and stuff like that.
Yeah, I mean, I think obviously it would be hard to have us pay for staff for the first 2 years or something, but I think there is something along the lines that we've been talking about, is how do you get the first 10 projects in the ground, and the support for those first 10 projects. And so it's
right. Yeah, exactly.
Troubleshooting, it's seeing what the issues are and incorporating that into your new designs. There's a whole bunch of stuff that would go into the first 10 projects.
Exactly. It's not just one single install somewhere, right? Because you've got to have a bunch of them. You know, we have several field units, and no, so that's exactly right. How do you support getting to the point where you have a viable project of those first 10 pilot projects, or whatever you want to call them, I guess.
Yep. Okay, great.
Okay.
Oh. Sorry, did you have a follow-up, Brett, or are we ready to go on to Robert?
Yeah, I wanted to hear from Robert. Nice to see you, Robert.
Yeah, good to see you. To me, the critical issue in the industry is scale. And the biggest obstacle to scaling, and I mean, you know this, we've talked about it before, is permitting. You know, DOE spent a lot of money on permitting and other technologies, which we won't discuss. When you have to start all over again, getting a variance for each individual project in every jurisdiction, it's just almost insurmountable to build scale. And if you had scale, even if you only have 2 or 3 companies that really have great scale, now you can bring in investors because there's a demonstrated potential market, and all of a sudden things take off. You know, and I know the federal government is really reticent to get involved in that because it's a local governance issue. The only instance I know where they did was in satellite dishes. They said you can't outlaw satellite dishes. And that was necessary for that industry to take off. I mean, we know when they started, they were like 6-foot dishes, and it would have been insurmountable to get a variance for a 6-foot satellite dish in every jurisdiction in the United States. We have to have a solution to this problem ultimately to get this industry to grow.
So how do you see that, Robert, playing into the kind of the current or future CIP model? So again, you could cover permitting costs in the first 10 or something of that nature, but this kind of national approach of, I mean, again, solar has spent lots of money doing solar cities and trying to entice and pay for communities to become solar ready, and that is to go through this whole permitting question. And so there are a couple of demonstrative models of how to do that. It certainly doesn't fit within the CIP construct. Do you see an overlap to the CIP construct, or is this just something that you feel the program needs to think about how to do more widely?
Yeah, it's just more the future of distributed wind writ large.
Yeah, no, exactly.
And yes, I agree. It doesn't fit in the structure of CIP, although that's promoting project demonstrations and providing for the permitting costs would be useful. It doesn't deal with the problem writ large.
Yeah, doesn't help much with the 11th project if that's in a new jurisdiction.
Yeah, it doesn't get you to the 1,000th project. I mean,
right.
SkyStream demonstrated how critical.
So I want to get to Erica here.
Yep.
Okay, good.
Well, Mike, if you had a follow-up on that point, let's do that. And then Erica, is yours something new?
Okay, just real quickly. So DWEA is advocating that DOE Wind Energy Technology Office work with the Solar Energy Technology Office on integrating distributed wind into their solar apps software. They are already integrating storage now, and so we see an opportunity to try, and they're out promoting that for communities. They've got hundreds of communities that have adopted that reduced easier way to get solar permits and soon storage. So but that's separate from CIP money. But we are very interested in that, and of course we would hope one day to have a federal preemption of local zoning.
Okay, thanks, Mike. Erica, yeah, go ahead.
Cool. Yeah, I have something new and then something also related to this conversation around permitting and everything. But on the new side, something I was going to say is that as an early stage technology, I know we still have a number of hurdles to overcome with certification, especially since we're doing something somewhat unconventional. And we're super grateful that CIP is working with us on that process now. And we're looking at getting support with air elastic modeling and maybe some of the wind prediction sides as well. But I think that's something that will continue to be needed integration with the lab before we get to certification as well. So I was just going to say that's having some mechanism to continue to interact with the lab on those things would be really useful for us. Unrelated to that, back to the permitting side, as Robert was talking, I was wondering, is there a world that could exist where maybe there's a certain area of the country that wants to, is on the cusp of wanting to be bought in on distributed wind, and maybe there's funding to test several turbines there and work through the permitting processes with them, with a vision for how those turbines could scale, kind of as a showcase project to help people get through those permitting areas, maybe just focused on a particular locality that's particularly good.
So I think that's an interesting idea. The regionality aspect, sort of blended in with this piloting to enable scale. So yeah, I think maybe potentially opportunities for that. The other thing I'd say is there are new and emerging models coming out of DOE and NREL that are actually looking at CIP as a mechanism for providing lab-based technical assistance to communities for energy transition planning, right? This is very, it's like take away small business and replace with small community. And, yes, some of the nuts and bolts are different, but if there was like just hypothetically here, a topic area that was designed to support community-based organizations with, revising permitting processes or ordinances to facilitate more wind deployment, that's absolutely something that could happen under a CIP-like model, and is already happening to some degree in other areas. I think one of the challenges we've seen with that is for a lot of these, we'll say maybe more technology agnostic initiatives that would provide that type of support, none of the communities put their hand up for wind. And I hate to say it, but wind does have that kind of, there's an aversion to it because it's up on a tower, it's spinning, it's a lot more visible. Some people love it a lot, some people don't. Solar doesn't seem to have that problem, and there's a lot more pull for solar. So I think part of that is, and I struggle with this. I don't know what we can do to help raise the visibility of the benefits of for wind and why a community would want to go through that process, right? Like, why would they want to use their taxpayer dollars to go through a process of, revising policy that has to go through a potential vote? If there's, and every community has these on every topic, a cohort of people that are going to be aggressively pushing back. I don't say that to discourage at all, but it is something we've seen, and I think that maybe the vision for the energy system of the future has changed with this administration, and maybe some of those minds that were previously closed to wind and these sorts of applications have reopened. So it's certainly worth revisiting.
Brent, something that's come through our ICOR SBIR work is an understanding of the market, both Intergrid's market as turbine OEMs and then our customers' customers. And one of the things that came up repeatedly was unusual applications, in particular EV charging, and how a wind turbine could be a signpost to say there's EV charging here. And so every rural gas station in the whole country could have a wind turbine as an indication that there's EV charging available, and as a little green flag for the property owner to show that they're charging cars with renewable energy, not coal, stuff like that. So I think unique applications could help grow the industry.
Mm-hmm. And good demonstrations of that might be nice.
Yeah.
I just want to point out that Heather just posted a comment about EV charging and the administration's objectives. So there might be a good synergy there.
Heather and I have a Vulcan mind meld.
And Heather, you have your hand up. So Heather, why don't you go, and then PK.
Okay, I'm sorry, I'm fighting off a little throat thing today, but yeah, I just think we need stronger goals being set for distributed wind, and a big focus on deployment in areas where large wind and offshore may not be as applicable. So hybrid systems with solar and storage, and put them along all the interstates where these charging stations are going to go. I saw recently that the feds put out a big goal for community solar. Here I'm posting another article about this. I think involving states in the deployment, I think that rebuilding these kind of state networks for distributed wind that sort of have dried up. I think, Ian, you mentioned that there's all these incentives requiring certification at the states. I don't know that there really are that many right now. Hopefully with the new influx of money, those will come back, but I don't know that we have the people in place at the state agencies that even know enough about distributed wind to make that happen. So anyway, I think that we've got to position distributed wind in there with solar, with EV charging, and just be a lot more ambitious in what we're looking for. This is the time to set our sights high. We've got this short window here, and let's not think too small. I guess that's what I want to think. Like, we've got a huge role to play here, and we've got the U.S. jobs. We've got a lot of good arguments for why this should happen. So let's try to keep growing.
Thanks for that, Heather. Well taken. PK, is that Patrick Kelly or a different PK? Padma? No.
Yeah, it's Padma.
It is Padma. Okay.
You're confusing us. You're being stealthy here.
I'm sorry?
You're being stealthy. You're confusing us.
I'm on my phone. I have no idea how to change it.
Okay.
We talked about permitting, but we focus on town permitting. I know that's a harder thing to bring under CIP, but utility permitting is an even bigger hurdle. And when we apply for interconnection permits, it's technical, and you would think a utility with a lot of electrical engineers would understand wind, but they just it's much easier to interconnect a solar PV system than a wind turbine, just because PV uses inverter-based systems, which are UL 1741 certified, but that doesn't really apply to all wind turbines. So even to permit a fully certified induction generator, we have to jump through hoops. The interconnection cost can go anywhere from $20,000 to $100,000, just because utilities don't understand wind.
So pulling on that thread, Padma, would the kind of the technical support be along the lines that we've talked about, how to develop the first 10 projects, and interconnection permitting would be part of that? Or are there kind of products, like stuff that you need to do, one lines, documentation, things of that nature that you could do for a turbine that would then allow you to hand it off to different utilities? So is it kind of materials that support in helping to develop the materials that you're going to need to support the interconnection, or is it actually the money to do that permitting at each utility?
It's not just it's not just submitting documentation. It's coming up with a system to show that, for example, the project I'm working on now, that it's a 250 kilowatt turbine. The utility is arguing that just because it's not UL 1741 certified, a regular relay testing, SEL 547 relay is not sufficient, because it's only passive anti-islanding, and somehow it is possible that the wind turbine will sustain an island, which is just not possible because of the variability of the wind itself.
Mm-hmm.
I was thinking more along the lines of coming up with a system to show that the same rules of solar need not apply for wind.
Mm-hmm. Okay, great. Thanks for that clarification. All right. Any quick follow-up on those thoughts from Padma before we move to James?
Yeah, I think that's an area that Brent and I can work on in the Codes and Standards Department, Ian. It's really an open question. Induction generators don't fit the mold. We know that. And so whether there's a ride-through requirement, whether there are ramp-up requirements, all that really needs to be dug into. And Padma makes a good point. I've worked with her a little bit trying to help with a full-blown effort, because there are other induction machines in the wings, like Endurance, that we have to solve the same problems with.
Mm-hmm.
Thanks.
Okay, great. Thanks, Rob. Other thoughts? All right, James, go ahead.
Jim Preslow, CBC Wind Energy. I'm a relative newcomer to the CIP process, and this will be the first time we submit an application. I'm amazed how little money is actually involved in the budget for this. $3 million a year is nothing. And I think there needs to also be an emphasis with whoever's reviewing the hypothetical changes to the program to remind people that, one, if we ever are going to get investors back to the small wind industry, they need standards. Otherwise, they're never going to invest. And this is creating those standards. This whole program, you have evolved the standards by which people know they're going to get a product. And the second thing is, you also need to remind them that over the course of the last 10 years, with all those failed projects that might have occurred during those 10 years, those are savings to both the investors and to the poor consumers that would have gotten stuck with some, shoddy product. And that's my thought.
Yep. Great, thank you.
Hey, James, are you a DWEA member?
I am not, and I need to join on. I'm actually one of those crazy lawyers. So, but I'm just seeing the big.
They use those too, I think.
Yeah, I'm seeing the big policy issues here, and I'm just like, 3 million. What? That's nothing. And if there's ever going to be a market again for these things on the investor side with the tax credits, we have to have standards, because we're not going to get anybody to trust us again until those standards are clear. And you have been developing those standards.
Yeah, and just building on that, a little soapbox here, I think one of the great things about CIP has been helping the industry design turbines to the standard. So the development of the standard, the improvement of the standard, and then working with all of you. I mean, it's all of you that are doing the work, is designing the turbines to meet the standards, not designing the turbine and then seeing if it makes the standards, if it can pass the standards. And I think that's a seed change in the industry that CIP has helped make happen. Helped you all make it happen, I should say.
And I can't pass up this opportunity to pitch Distributed Wind Energy Association. Thank you, Brett, for teeing it up. But that's if you feel that the $10 million distributed wind budget at DOE, or the $3.5 million for CIP is insufficient, as a lot of us do, the way you can change that, help to change that, is to join the Distributed Wind Energy Association. We have a range of membership categories. It's reasonably affordable. We have a lobbyist in Washington, and we work to create business opportunities for our members. So if you are not a member of DWEA, please, reach out to me. I'm the president, mberge@berge.com. And I will give you whatever information you need. But we have a very active association. We get a lot of, you're getting mailings every couple of days. We have federal policy updates once a month, and we hold a conference, or used to hold conferences. It's a very good group, and we would welcome all of you who are not members to join in.
I will definitely do that. And I should also state that I come from a very small state, and all 4 of our congressional members are Democrats. So being from a small state, everybody knows everybody, and I'm definitely going to be pushing to say, how could this possibly be such a small budget?
Thank you.
Great. Thank you all. All right, we're hitting the top of the hour. Any last comments? Brett, do you have any last comments?
No, I really appreciate all the discussion here and sort of the open format to have a free and open exchange like this. We don't get to do this often enough. But I've definitely got some great notes here, and I personally am very optimistic and excited about the prospects here moving into the future. And I really do think that, again, CIP doesn't necessarily have to go away. Maybe it stays as is, but we've got a mechanism that we know works, and it would be nice to test it out on some more deployment focused work. And so you've given me some good ideas here, and look forward to receiving some good proposals.
Thank you.
Everyone, does everyone that can want to turn their camera on for a quick group photo for the archives?
And while Brent, while you all do that so that Brent can take the photo, just want to again restate that we're all here from the NREL and DOE team to support. And so if there are things that's jogged in your brain and want to have ways to support CIP or ways that we can chase CIP, Brett clearly, and then myself, always have an open phone line. So don't hesitate to reach out at any point. If other things come to you or things you didn't want to bring up in this group setting, but you would like to advocate for, please don't hesitate to do that. Lastly, as we're coming down to the end of the hour, just want to again thank Brett and Patrick at DOE for supporting this program. They don't get enough credit for the defensive actions that they take at DOE to make sure that this happens. So this is successful because of them and their commitment to this industry. And then I'll also want to thank the NREL team that I have the pleasure of leading, who make all of this work. So the proposal review, but then also working with all of you to make sure you're successful. That's our goal here, and the team here tries really hard to make that happen. So thanks to them. We have, again, the sessions tomorrow. This is the last time all of us will be together, but we have the sessions tomorrow. So please dive into those, the ones that are of interest. And again, those will be recorded and broadcast. So if you can't make one, just keep coming back to the CIP website, and we'll have those up there as soon as we can. And then one last time to say, if you want to talk about your specific technology and where you think it fits in, please don't hesitate to reach out to Brent, Summerville, and I, and we'll set up times to kind of talk through those so that we make sure that you're writing a proposal that has the highest chance of being successful when and if that RFP comes out. And then if you have submitted for last year and were not successful and want a debrief, please reach out to Kyndall to highlight that you do want to debrief, and we'll debrief that. Chances are we're going to want to do that debrief before we have a formal dialogue about how to approach the next one. So reach out to Kyndall quickly, and we'll follow up with those. So it's the top of the hour. Thanks again to everybody. We certainly appreciate all of you and all the work that you're doing to move this industry forwards. And as Brett said, we're on the cusp of great stuff, and I think the industry is prepared for that, thanks to the work that all of you have done. Did you get
Thanks, everyone.
Yep. Okay.
See you tomorrow. Yeah, I'll
Take
get
care,
photos.
everybody.
Thank you.
Okay. Bye all.
Bye.